Once we know how to identify the different forms of our quadratics, it's important to know what to do with it. So where are we headed anyway? The most important thing that we are trying to do is find a solution, an answer to our problem. That's the whole point of math, is to always find an answer to your problem. So when we're looking at quadratics, specifically with these parabolas, we are going to find the solution. The solution is also called a root. It is also called a zero. And as we move forward, we see why solution, root, and zero all make sense. For some of the forms, we're just finding an answer, which is the solution. We may be doing it by finding roots. We may also be doing it by finding the zeros. So all three of these words mean the same thing. We are finding the answer for our problem. So the way to do that whenever you have a quadratic, which simply means that one of your terms is squared on that, there are 4 different ways. We can factor, we can find a root, we can complete the square, or we can use the quadratic formula and the discriminant. All of them are ways of finding the solution. Different quadratics will be found more easily with one form or the other. But again, it comes down to personal preference of what you want to do. So why are they valuable in the first place? Well, those factors that we found whenever we were working over factoring out a quadratic and getting into their 2 separate binomials, the factors are extremely important because they help us answer the question when y equals 0. So just as we did with linear equations, we were asking when y equals 0, what is x? When x equals 0, what is y? That gave us those specific intercepts. So it's important because the intercepts are our solution. It is the solution for where your graph crosses the x-axis. We are always wanting to answer the question when y equals 0. So once we have it factored, the rule is if your answer is 0, then one of your terms must absolutely be 0. So if I have 0 equals 5 times something, my question mark must be 0. There is no way to get a multiplication problem have the answer of 0 if one of the terms is not 0. So it doesn't matter how many terms I have. As long as one of them is 0, I will get the answer of 0. So in the same way, we use that same logic to apply to our factored quadratic. So I'm wanting to answer the question when x equals 0. Well, when x equals 0 means that one of these terms absolutely must be 0. So either x plus 2 must equal 0 or x minus 3 must equal 0. I can solve for both of these. In the first case, we have x is equal to -2. In the second case, x is equal to +3. I have moved my numbers over. So both the solutions, -2 will make this equation 0, and +3 will also make this equation 0. So that tells me that I have 2 places on the graph. I have a -2 when y is 0, and I have a +3 when y is 0. Both of those are locations at which the graph lies along the x-axis. So if we look back and we say it's a solution, a root, or a 0, we can see that we found our solution by finding where they were 0. So that's our tie to why they are called zeros. Okay. An important thing to know, once we have used a factored equation and we have gotten those 2 roots, those 2 zeros that lie along the x-axis, they lie on the same y plane. We know that they lie on the same y plane because y is equal to 0 to them. So one of the things that we can take from our previous lesson on parabola is that a parabola is always symmetrical. We can always fold it down the middle. And the term for that was the axis of symmetry. We learned last time that our axis of symmetry always goes through the vertex, and it is equal to the x value of the vertex. It is the place where we can take our parabola and fold it in half. So if I have 2 points that lie along the exact same line, we can find the middle of them by adding them and dividing by 2. We're simply averaging to find in the middle. So in this case, I had a -2 on one side and I had a +3 on the other side. Y was 0 for both of these points. So I know I have 2 units on one side, 3 on the other, so I have 5 units between them. 5 divided by 2 gives me 2.5, so the very middle is going to be 2.5 from either of those. So I can either count forward 1, 2.5, or I could count backwards 1, 2.5. Either way, that point lies along x equals 1/2. If my axis of symmetry is x equals 1/2, it means that the x value of my vertex is also 1/2. Now that I know the x value of my vertex, I can plug that directly back in to my equation, and I could find the y value of my vertex in that case. So as we plug in 5/2 there, if we're looking for our x value, if I plug in 1/2 here, and so then I am adding it across, I get -2.25 is where my y value lies. So again, we learned a lot of information from 2 little points. We factored our equation, we got the 2 points that were our intercepts, the zeros of our graph, the solution to our problem, and from that we were able to find the axis of symmetry, and we were also able to find the vertex. Okay, so in this case, if we are given an equation and we want, we can say, hey, I think I can factor that. Factoring is a very quick way to get all of the information that we need at one time. So we would simply write out our 2 binomials. Our first term gets divided into 2. Our second term, we're asking ourselves, what 2 numbers are both multiplied together to be 88 and then added to be 19? And we could say 8 and 11. 8 times 11 is 88. 8 plus 11 is 19. All of my signs are positive, so I would have positive signs here. And I would have the zeros of my graph would be x equals -8 and x equals -11. So if I were graphing, I would be able to put one point at -8, 0, another point at -11, 0. I would be able to say that there are 3 units between this. So I've got to go over 1.5 to get to my middle, which would be 9.5. So at -9.5 equals x would be my axis of symmetry. And -9.5 is also the x value of my vertex. And so at that point, we have everything that we need to be able to graph this equation. On number 2, the first thing that I'm going to notice is that the coefficients of all of my numbers involve a 3. I can remove a 3. If at all possible, you always want the coefficient of your squared term to be the number 1. In that case, I want to get rid of both the 3 and its negative sign. Since I'm going to factor out the negative sign, I'm going to be left with x squared. When I take a negative out of a +3, I have a negative left over, so -x. Again, a negative out of a positive leaves me a negative left over of 30. Now I ask myself the question, are there 2 numbers that I can multiply together to be 30, yet subtract them to be 1? And I say, yes, I have 6 and 5. 6 times 5 can be multiplied to be 30, but they are subtracted to be 1. So which one do I want to be positive or negative. In this case, I want my answer to turn out to be negative. So my larger number must be the negative sign and my smaller number must be the positive sign. That gives me x equals 6 and x equals negative 5. So if I were graphing, I would have a point at 6, 0. I would have another point at negative 5, 0. I know that my axis of symmetry lies right in the middle, which is going to be 5.5 over. So I'm going to go 5 this way and then 1/2. So x equals 1/2 is where my axis of symmetry lies. That means that the x value of my vertex must also be 1/2. So again, we get all of the information that we need to be able to graph and solve for the zeros of our graph from factoring our equations.